So we're now going to see a problem with a secant type of substitution. I've put up the relevant substitution rule, but of course you're going to have to learn how to recognize these from the three possibilities. So here you can see is that if you have square root of b squared minus x squared, b squared x squared minus a squared, you're going to use the substitution x equals b over a secant theta. Here what we can easily see is that if I map this form onto the actual problem, sorry, where's my pointer? If I map this form onto the actual problem, what we can see is that 4 is equal to b squared and 36 is equal to a squared. So that's going to give us a equals 6 and b equals 2. So back up. So we're now going to do a problem with a secant type of substitution. I've put up the relevant rule over here. You're going to actually have to learn how to recognize which rule applies from the three possibilities, but since this is the third of them, I'll just put up the relevant rule. What you can see if we map this expression, where's my pointer, this expression onto this, what we can see is that the 4 here is equal to b squared and the 36 is equal to a squared. That is clearly going to give us a equals 6 and b equals 2. So we're going to use the substitution x equals 6 over 2 secant theta, or just written better, that's going to be x equals 3 secant theta. Dx is therefore going to be 3 secant theta tan theta d theta. Okay, so we can now evaluate the original integral. The original integral is now going to be, we need dx, so that's going to be 3 secant theta tan theta d theta over, I have x squared is going to be 9 secant squared theta, and in the square root, I've got 4 times x squared. So let's see, that's going to be 4 times 9 secant squared theta minus 36. So simplifying this a bit, we have 3 secant theta tan theta d theta over 9 secant squared theta, and then I have square root, 4 times 9 is 36, so as you can see I'm just going to have a factor of 36 that I can pull out like that. So that's going to be square root of 36 secant squared theta minus 1 under that radical. So this is going to be the integral of 3 secant theta tan theta d theta over 9 times the square root of 36. Square root of 36 is 6, so that's going to be 54 secant squared theta. And then to deal with this term here, secant squared theta minus 1 is tan squared theta. So when I take the square root of that, that just becomes tan theta. So write that a little bit neater. Tan theta, like that. Okay, so you can see that we're going to get certain cancellations here. We're certainly going to be able to cancel this. This 3 over 54 is going to become 1 over 18, and secant over secant squared is just going to become 1 over secant theta. So this now becomes the integral of, actually let's put the constant outside, so that's going to be 1 over 18 times the integral of secant theta, sorry, actually not secant theta, it's just going to be 1 over secant theta. So we have d theta over secant theta. And of course that's just going to become, since secant theta is just the reciprocal of cosine theta, this just becomes 1 over 18 cosine of theta d theta, which we can evaluate the antiderivative straight away. That's just going to be 1 over 18 sine theta. So now we just need to do the back substitution. We write the triangle, and let's see, x equals 3 secant theta. So that means that x over 3 equals secant theta. Secant is hypotenuse over adjacent. In other words, it's the reciprocal of cosine, which is adjacent over hypotenuse. So the ratio is x over 3, hypotenuse over adjacent, and we can now fill in the opposite side, which becomes x squared minus 9. And we're now ready to fill in the answer. The answer is just 1 over 18 sine of theta, so that's just going to equal 1 over 18 of sine is opposite over hypotenuse. That's going to be x squared minus 9 over x. So we're just going to put this in a little bit of a nicer form. Square root of x squared minus 9 over 18x plus c. And there we go. That's how you would do that problem.